guys, how are you all? I hope you all are doing well. So I'm here into my today's video with the subject of group theory. So I started inside group theory, which is a Cosets. I uploaded some videos on Cosets and their examples also. In my today's video, I will explain to you all some of the examples from Cosets chapter, because this one is the most important to understand that factor group or invariant subgroup and other remaining topic too. So for understanding that one better, we need to understand first of all Cosets, and this one is more important for our competitive exam too. So here I am here with one example from Cosets chapter. We want the cosets of D4. Okay, so I consider here dihedral group. Now let's get started our lecture. I will explain how to find the cosets of this dihedral group. Now here example, first example is I mentioned here G as a dihedral group. Okay, dihedral group of order 4, and I consider it's a subgroup R0 R180. Okay, so these two are the identity element. Okay, these two are the identity element of a D(n) of order 2n. Okay, so dihedral group, it is having order 4, means 4 into 2. That means the element contained in dihedral group, it is totally 8. Okay, D(n) of order 2n. That means dihedral group is having 8 elements, and which are R0, R90, R180, R270, and R360, means R360 equal to R0. And it is having rotation H, V, D, D dash. Okay, horizontal, vertical, diagonal, anti-diagonal. That means it is having reflection and rotations are equal. So these are the total 8 elements from our dihedral group of order 4. And I consider its subgroup from our dihedral group is R0, R180. And we want the coset of K in D4. Okay, so K it is here in a D4. So K in a D4, it is the center of D4. Okay, so it is center of D4. That means this is the center of a group G. Because when we take any element from here, xy which is equal to yx, it gives. So that's why we call it as the center of group. So center of group I already explained in my previous videos. If you want that center of G concept more clear, that you can check it into my other videos also. So if you are doubt related to center of group, you can ask me. So now let's get started further. I consider K it is here as a subgroup, and which is the center of D4. D4 contains these many elements. Now, as per the definition of a cosets, take any element from group G and add it into our subgroup. Okay, but when we add and when we subtract, when group is a cyclic, like Z4 group is there, it is additive group, then we add these elements. But when D4, it is a multiplicative group, this one is a multiplicative group, so then we have to multiply. If group is multiplicative, then multiply, and group is additive, like previous example, like a Z4, then add the element. Okay, now take any element from the D4. I consider R0 from D4. Okay, so I can consider R0 and take it into our subgroup. So okay, R0 into our subgroup is a K. So R0 into R0, R180. Okay, under curly braces, R0, R180. Now multiply R0 to this bracket. So R0 into R0, identity into identity, always identity. So R0 into R180, always R180. Okay, so R0 into K, we get the R0 into R180. This is our first coset. Now let's move for the second coset. Consider the second element from our group. I consider here R90, so which is from D4. So R90 into K. So R90 into K, that means R90 into subgroup, which is a K, R0, R180. So multiply this one under bracket. So R90 into R0, R90 into R0, R90 into R180. It is here. So R90 into R0. R0, it is identity element. So we get the R90 here. Okay, this is R90. And R90 into R2, 180. So I want their multiplication. Okay, so you can find it through the graphical presentation. Like you can draw R1 180 and then try to rotate. First of all, draw a triangle which include the values 0, 90, 180. Okay, then try to rotate that one R180 first, and then go for rotation of R90. But I feel that the simple way, what you have to do, you have to add both of them. Add them. If it exceeds than 360, then try to take it into under 360. Okay, so R90 into R180, 90 plus 180, 270. So you have to add it directly here. You will get the next rotation. So here I got the second coset here. Now let's go for the third coset, R180 into K. Okay, R180, it is from our group. It is here. We have to take all elements from D4 and multiply into our subgroup K. So I consider R180 here, R180 into K, R180 into K. So multiply inside bracket R180 into R0, R180, R180, R180. Simple way, add them. R180 plus R180, R360. But R360, which is equal to R0. Both are having same value. So R180, R0 here. So this is our next coset. Let's move for the R270. Okay, let's move for the R270 here. Into K, R270 into K. Multiply R270 into R0, R270. R270 into R360. Okay, R270 into R360. Add both of them. add them, and you try to convert into the R360 form. So you will get the here 450, you will get that one. Okay, so try to take it into the 360, you will get the R90. Okay, this is the rotation. If it get exceed than 360, try to take inside 360. So R270, R90, it is there. This is the next coset. Now it's left over here for the reflection. These are the rotation we done it here. Now let's go for the reflection. Reflection, we know that horizontal, vertical, diagonal, anti-diagonal. So multiply horizontal to their subgroup H into that subgroup, H into R0 H into R180 V. Okay, so we have to find first of all R180, then you will get the V. Okay, so H into R0, it remain H into R180. First of all, try to rotate R180, then you will have to go for rotation reflection of H, then you get the phi vertical. Okay, similarly do it for phi into K, phi multiplied by R0 into R180. Phi into R0 identity, it remain phi into R180. Okay, so first of all find out R180, then find out vertical, then you get the horizontal. Okay, so it is H phi. Again similar do it for diagonal. Diagonal means diagonal into R0, R180. So diagonal into R0, diagonal itself, diagonal into R180, diagonal, anti-diagonal it is here. Okay, so you have to find out the rotation. Now let's go for the next diagonal, anti-diagonal into our subgroup R0, R180, which is a D dash, R0 into D dash, it is anti-diagonal itself. Anti-diagonal into R180, we get the diagonal. Okay, so this is the next one. So you can see it here. These are the our dihedral element, group element, that we get their cosets. Okay, so you can see it here. I got R0 into K, R180 into K. These are the equal. So as we can observe, DK dihedral group into subgroup, and anti-diagonal group. Okay, diagonal group into subgroup, and anti-diagonal into subgroup, both are equal. So you can check it here. D into K, which is a D into D dash. Okay, D dash into K, D dash into D. So I gathered it here only them. Okay, so both are equal. Similarly, it is equal here. This one is equal and this one is equal. Okay, so you can get these pairs are equal. And then here we have R0K, R90K, HK, and DK. Okay, horizontal into subgroup. K is the subgroup here. Diagonal into subgroups are 4 distinct cosets. Okay, so as we take them at once, we get the only 4 distinct cosets. Their union gives a dihedral group, whole dihedral group, and their intersection give empty group. Okay, so this is the example from our dihedral group. I selected here for finding their cosets. Okay, and you need to remember, if a group is abelian, then left coset and right cosets are equal. But we know that dihedral group is not abelian. Okay, so we cannot write that left coset and right coset equal here. So I hope so you all have understood my today's lecture for finding the cosets. It's quite easy. We just have to verify only the last 2 properties, which is their union, our group, and their intersection. It is empty set. Okay, so I hope so you all have understood. If you want similar lecture, you can comment me in the comment section. For more videos, you can check it into my playlist. If you need any help, you can ask me in the comment section.